Okay, so vertex form of a quadratic. This is our vertex form. We have three variables that really affect how we're going to graph our quadratic. We have the a, which we know stretches vertically and compresses vertically and also flips the parabola. H does horizontal translations and k does vertical translations, right? Well, also in our vertex form, the reason they call this vertex form is because it turns out that H and K are actually what the vertex is, okay? It turns out that our vertex, the x and the y value of the vertex, are precisely our H and K. Now the K is really straightforward. Whatever this whole value is, that's the y value of the vertex. H is a little opposite, okay? So think of it like the opposite of H. So I'm going to be like a negative of H here. Because really what's happening is in this formula we have a negative value, okay? So let's say, for example, I just give us a function f at x is equal to, I don't know, negative 2 x minus 2 squared plus 3. Okay. Well, the vertex of this we can see right in the equation.
2 and 3.
That's right, exactly. The 3 will be our y. It's exactly as said, positive 3. And even though this is negative 2, we use the inverse of that. So it's going to be positive 2 in this case. Now the reason that is because if I were to take the vertex and plug it into vertex form, see this equation already has a negative to it. Okay, so really what's happening, let's say we already knew that the a was 2. Okay, so I write the a and I get negative 2. And then I get x minus a value. Well, this is positive 2. That's what I replace my h value with. The real h value is positive 2. Okay, and I'm just going to take away this negative because that's not mathematically correct. Squared. And then the k value is, well, positive 3. Well, everything's good except for in here, this needs to be simplified a little. The way this would be simplified is the same as writing x minus 2. Okay, and that's why it comes out as an opposite. We have the squared and we have the negative 2 here. So this is the reason it comes out as an opposite of what we actually write. Okay, now our original vertex, and we're going to go into some simplifying here. Remember I talked about originally our a value is 1, our h value is 0, right? It's negative 0 squared, and our k value is 0. Okay. Well, I'm going to go into some simplifying here. What is x subtract 0?
0. No, x.
X, right? So now I'm left with 1 x to the power of 2 plus 0. Well, x to the power of 2, how can I simplify that? I can just write it as x squared, right? I can get rid of those brackets. So I have 1 times x squared plus 0. Whenever we add 0 to something, is that going to change the value? No. So how can I simplify this farther? I can just write what?
1x squared.
1x squared. And what is 1 times x squared going to be?
1x squared. 1 times x squared?
Yeah. Will the 1 change this at all?
No.
So how can I write it even simpler?
X squared.
X squared. So if you notice, I've just gone from here to here without doing anything. I just simplified it. So really, this is our original equation when they write f at x squared. But if you notice, I've given values to the vertex form. So in this equation, what is the value of the vertex?
0 and 0.
That's right. The value of the vertex is 0 and 0. That's the x and y value. Okay, that's important because now what we're about to do is we're going to jump over. Here's our equation. When we zoom in, you'll notice the vertex is at 0 and 0, and that's the equation we've written here. Okay? Now we should talk about how to graph this. So we'll jump back over. If we need to graph this equation, okay? We talk about a values and what we do with them when graphing them. Okay? What we're going to do is we actually have to multiply by our a values. So one of the tricks is, I'll jump to another page. So let's see how far. Yeah, let's get another page. So let's say we go to graph this. We're going to bring up a graph. Scale of 1. So that's similar to the other graph. We're writing y equals x squared. That's the original one. right? Well, like we said, the vertex of this guy is at 0 and 0. So that means our vertex is right there. Now, I want you to think of this. We could go about this the long way and make a table of values to solve this. Like I could put a -10, -9, all these. But what we're going to do is we're going to focus around the vertex being at the value of 0. Okay? We're going to do some of this calculating in our head. So at this value, this is the x value of 1. Okay? So I'm going to put the x value of 1 here. And then if we were to move to the left of the vertex, -1. Okay. Now I want you to think like this. Remember, the a value here is technically the number 1. So if we go to graph this, I'm going to take these values I moved from the vertex, 1 over, and I'm going to square it. What is 1 squared?
1.
1. So I'm going to move up 1. So I go over a value, up 1 value. But we always have to multiply by whatever our a value is. Well, what's 1 times 1?
1.
Still 1. So we go over 1, up 1. And we do the same thing here. Over 1, or -1 squared is 1 times 1 is 1. Confusing because there's a lot of 1s. Let's go back to the vertex. Now we're going to go over 2 units. What's 2 squared?
4.
4. We got to multiply by our a value. What's the a value?
4.
Yeah, 1 times 4 is still 4. So we go over 2, up 1, 2, 3, 4. This is our next major point.
Is that how you would write draw
The parabola. Yeah. So then, let's say we go back to the vertex. Let's say I go over 3 units. What is 3 squared? 9 times 1 is still 9. So we go all the way up to 9. And it's symmetrical on the other side. So here's the original parabola. Okay. But remember what we talked about. Let's take that other parabola I'd written out. I had written it as, what were my values? -2, x minus 2 plus 3. Great, let's take that guy. F at x is a different one, okay? So we'll write it in red. F at x is equal to -2, x minus 2 squared plus 3. Well, first off, where is the vertex of this one?
2 and 3.
That's right, so we're at 2 and 3. So right away, I can just jump to 2 and 3. Here's my vertex. Now, my a value is -2. So this is going to change things a little.
It's going to go down.
Yeah, so if I go over 1, what's 1 squared?
1.
1. Times -2?
-2.
Ah, so I go over 1, negative, I go down 2. So here's our first coordinate for the blue. Okay? And remember, it's always symmetrical on the other side. So we'd go over 1, 1 squared is 1, times -2, we'd go down 2. Okay? So here's the first point. We go back to the vertex. We go over 2 units. What's 2 squared?
4.
4. But we got to multiply by our a value. What's 4 times -2? -8. So we go over 1, 2, and down 1. 4, 5, 6, 7, 8. We've gone down 8. And symmetrical on the other side. So it's going to be here. And then finally, this one's not even going to show up. If I go over 3, what's 3 squared?
9.
Times -2?
-18.
So not even going to be on this chart, right? It's going to go flying way off. So here is our other parabola. This is much thinner and flipped because of it being negative, okay?
So that means it's stretched, right?
That's right. It's been stretched when it gets thinner. So let's type in that other equation here. The other equation, we said -2, x minus 2 to the power of 2 plus 3. Whoops. Well, that's not what I wanted. Oops, sorry.
So if it's if
3.
if
There
it's
it is.
less than 1, it's compressed, and if it's over, then it's stretched. Okay.
Pushing the wrong button every time.